This is Gagan Girotra, IIT Roorkee class of 2000, and I am Calcutta class of 2005. In this section, we are going to talk about relative speed. Now, relative speed is essentially the speed of one moving object with respect to another moving object. Okay. Now, there are certain conditions that you must wait for to apply the concept of relative speed. Now, the first thing that you would have to remember when applying the concept of relative speed is that both the moving objects should be moving along the same straight line, right? So it is not that you can have one object moving in this direction and the other object moving in this direction. Okay, so the concept that we are going to study will fail in this situation. So in the situations that our concept is going to be applicable, they will either be moving, both the objects will either be moving in the same direction along the same straight line, or they may be moving in opposite directions but along the same straight line. Then if in certain questions you may also be faced with a prospect that there are more than two moving objects. In that case, if you are required to apply relative speed, then you will consider two moving objects at a time, right? Do not think of applying relative speed when there are three moving objects. You cannot apply this concept to three objects together. So what you will do is you will take two objects at a time, do your necessary calculations based on relative speed, and then maybe pick the first object and the third object for your second round of calculations. The third condition that you will remember is that in case the moving objects are starting and stopping at different times, right? In that case, you will apply absolute speed for the duration when only one object is moving. Now, this is likely to happen at the beginning of, let's say, the time when it is given that the first object starts moving and the second object has not yet started to move. During that duration, you will apply absolute speed. You cannot apply relative speed during that duration. But you are free to apply relative speed as soon as the second object starts moving, right? So when both the objects are moving for exactly that duration, you're going to apply relative speed. Now what happens is that in some questions, one of the objects stops moving. Now as soon as this object stops moving, you will stop applying relative speed right away, because now again only one of the objects is moving and you will move back to absolute speed. Right. Now just like absolute speed, the relative speed is calculated as relative distance divided by time. Okay. Now the concepts to study for us now are the concept of relative speed itself and the concept of relative distance. Now relative distance, just like relative speed, is the distance covered by one object with respect to the other. And there are two ways of calculating relative distance. The first method of calculating relative distance is by using the absolute distances that have been covered by both the moving objects. Yeah. And the second method of calculating relative distance is by using initial and final gap between both the objects. We're going to cover this in greater detail in the following slides. Right, so let's start with the relative speed. Now, in relative speed, you can have either both the objects are moving in the same direction, or you will have both the objects moving in the opposite direction. Now, when both the objects are moving in the same direction, you could have the faster object, the faster moving body, following the slower moving body, right? So let's say we have this cross A as the faster moving body, and the cross B is the slower moving body, and A is chasing B, right? So in this case, we will have the relative speed as the speed of A minus the speed of B, right? You can have another situation when both the objects are moving in the same direction. You could have the faster object is ahead of the slower object and the gap is being created. In the previous case, the gap was being reduced by A. right? A was coming closer and closer to B as both of them moved in the eastward direction. Now A is moving ahead of B, right? And A is opening up the gap between A and B. Even in this case, because both of them face the east direction, the relative speed is going to be speed of A minus the speed of B. Now how about both objects moving in the opposite directions? Now when both objects are moving in the opposite directions, you can have either both of them are moving towards each other. So let's say if this is A and if this cross represents B, they're both moving towards each other. Or you could have a case where both A and B are moving away from each other, right? In both these cases, you will notice that both A and B are facing the opposite directions. In this case, A is facing east, B is facing west. In this case, A is facing west and B is facing east. So in both these cases, the relative speed of A with respect to B will be speed of A plus speed of B. Here SA and SB are all absolute speeds, right? So we've used absolute speeds to calculate the relative speed. Now in case of relative distance, we'll use the first methodology where we use absolute distances to calculate the relative distance. Now just like the previous case where we calculated the relative speed, we will now consider two cases. One is when both objects are moving in the same direction and we have the absolute distances that they cover. And the second case when both objects are moving in the opposite directions and we still have the absolute distances that they cover. Now when both objects are moving in the same direction, let's say we have moving object A here and we have moving object B here, right? And let's say A travels to this point A dash, right? In the same time, B travels to this point B dash. Okay, so in this case, you notice that A and B have both traveled in the same direction, and we have their absolute distance covered by A, which is AA dash, and we have the absolute distance covered by B, which is BB dash, right? In this case, the relative distance is going to be the difference between the absolute distances, right? So the relative distance here will be given by, in this case, we notice that BB dash is greater than AA dash. The relative distance will be BB dash minus AA dash, right? Now, in another case, if both objects are moving in the opposite directions, right? So let's say you have A here and you have B here, and A is moving in this direction, and let's say A moves to this point A dash and B moves to this direction in the opposite direction, and B reaches this point B dash, right? Then the relative distance covered is going to be equal to the sum of their absolute distances, right? Now in this case, while we notice that A and B have traveled in the opposite direction, right, the distance covered by A with respect to B is the sum of the distance covered by A and the distance covered by B, right? Moving on, the second method of calculating the relative distance, when we know the gaps between the two objects, right, we will have in this case we will not worry about the directions in which they move. Okay, in this case we will worry about whether they have crossed each other or not, right? Now crossing is obviously they're both moving in the opposite directions and they cross. Overtaking is when they're moving in the same direction and the faster guy overtakes the slower guy, right? In relative distance calculation, when we know only the gaps, we will worry only about the crossing overtaking, right? So in the first case, let's say there is no crossing overtaking. In the second case, let's say there is crossing or overtaking. Now if there is no crossing or overtaking, now what happens is, let's say A and B start from here, okay, and A moves in this direction and ends up here, A dash. Likewise, during the same time, B starts from B and ends up at this point, you notice that there is no crossing which has taken place, right? So in this case, the relative distance covered will be the initial gap, which is AB, right, minus the final gap, which is A dash B dash, right? So in case there is no crossing or overtaking, the relative distance is going to be the difference between the two gaps. So if we know the initial gap and we know the final gap, the relative distance is going to be initial gap minus the final gap. Now in this case, obviously they moved towards each other without having crossed. The same formula will be applicable even when they have moved away from each other, right? So let's say A and B start from here, and A goes in this direction and B goes in this direction, and A ends up at A dash and B ends up at B dash. The relative distance will still be the initial gap AB minus the final gap A dash B dash. The only thing to remember here is that you will need the absolute value. Okay, so please adjust the relative distance that you've calculated. If there is a negative sign, please remove the negative sign. Now let's say they have crossed. Let's talk about the other case when they have crossed during their movement. Now if they cross, now let's take an example that A starts from here and B starts from here, and A moves in this direction, right, and A reaches here. B starts from the other direction, okay, and B reaches here. Now you notice that during their commute, during their movement, both A and B crossed somewhere here. Okay. Now in this case, the relative distance is going to be the sum of their gaps. So if we know the initial gap AB, and we know that they crossed, and we know the final gap A dash B dash, the relative distance is simply going to be AB, the initial gap, plus A dash B dash, the final gap. So let me write it down here. So relative distance in case crossing does take place equals the initial gap plus the final gap. Now if you notice these dotted lines, and if you remember what we've just discussed in the previous slide where we talked about measuring the relative distance using the absolute distances, you would notice that AB plus A dash B dash is exactly equal to the sum of distances that they've covered, right? So you will always arrive at the right answer if you just use this simple methodology of figuring out whether they've crossed each other or not. Okay, and in terms of knowing the gaps, if they've crossed, just simply go ahead and add the gaps. If they've not crossed, just go ahead and deduct the smaller gap from the bigger gap. Thanks for watching the video. You can give your feedback in the comments section below. Please click the like button if you thought the video was helpful. For lesson updates, you may subscribe to my YouTube channel People Plus, or you may read my blogs at peopleprep.com, or you can directly connect to us through our Facebook page @PeoplePlus, or you can email to me at gagan@peopleplus.com. Thank you.